So, in this next section, we're going to talk about independent events and also get a handle on how the multiplication rule works in probability. So, two events are independent, which basically would mean that the chances of one event happening has no impact whatsoever on the chances of the other event happening. If that is not the case, then events are said to be dependent. So, for instance, if I'm going to flip a coin 2 times, each toss of the coin is going to be independent from all previous tosses. The coin does not care what I may have flipped 50 times previously. Every time I get the coin in my hand, ready to flip it, it's a clean slate, a fresh start. It does not matter what has happened previously. There's actually something known as the gambler's fallacy, where people think, oh, I've lost at craps for the past 2 hours. My luck's bound to change if I try it the roll of the dice the next time. And of course, that's false. That's probably a good sign to stop gambling at that point. So events that have no effect on each other, those are said to be independent. The dice do not care what you've rolled previously. It's a fresh experiment every time. So, by definition, E and F are independent events if and only if, this is the definition here, if the probability of E and F is equivalent to the probability of E multiplied by the probability of F. So if you multiply the two individual probabilities together, and it turns out to be the same as the probability of both of them happening at once, that means they are independent. If you have more than just two, if you've got a whole string of events, it's just every individual event probability multiplied together. So if there's like 5 of them, you multiply all 5 of them together. We've mentioned before, mutually exclusive means that the probability of E and F is equivalent to 0. So if the probability of E and the probability of F are not equal to 0, that would mean that they are dependent events. So, a standard 6-sided die is rolled 3 times. Find the probability of rolling only 1s. Well, the chance of rolling a 1 is 1 out of 6. And then because we're doing this 3 times, we're going to multiply 1 out of 6 3 times. 1 times 1 times 1 is 1. 6 times 6 times 6, also known as 6 to the 3rd power, is 216. That would be the probability of rolling 3 1s. Next, what are the chances of rolling 1s on the first 2 rolls and then rolling anything other than a 1 on the last roll? Well, 2 1s for the first 2 rolls. You'd have a 1 out of 6 for the first roll. You have a 1 out of 6 for the second roll. The chances of not rolling a 1 for the last one, that is the complement, which in this case would be 5 out of 6. So this would be 1/6 times 1/6 times 5/6. Multiply all the numbers on top. 1 times 1 times 5 is 5. Multiply all the numbers on bottom. 6 times 6 times 6 is 216. What are the chances of rolling exactly 2 1s? So it does have to be exactly 2. We don't want 3. We don't want 1. We want exactly 2 1s. Now there's a couple ways this could happen. You could have you could have a 1, and then something else. You could have a 1, something else, and then a 1 for the third one. Or you could roll something else for the first roll and then have a 1 for the second roll and a 1 for the third roll. So there are 3 ways that this could happen. And this is different, you may notice, from this one here where it says rolling ones on the first 2 rolls. And so it did specify the order that the events are happening. So for rolling exactly 2 ones, there are 3 ways that it could happen. And we're going to multiply the 3 ways it could happen. And then there's a 1 in 6 for getting a 1. There's a 1 in 6 for getting another 1. And finally, there's a 5 out of 6 chance for getting a 1 that is not 1. So then 3 times 1 times 1 times 5 is going to give you 15. 3 is equivalent to the fraction 3 over 1. On the bottom, 1 times 6 times 6 times 6, that is 216. So there would be 15 out of 216 ways to get exactly 2 ones from 3 rolls of the dice. What is the probability of exactly 1 1? Okay, so the chance of getting a 1, there's a 1 in 6 chance of that happening. To not get a 1 for the second roll is a 5 out of 6 chance. And to not get a 1 for the last roll is also a 5 out of 6 chance. As before, we have to think of how many ways we can mix and match getting only 1 1. So you could roll 2 results and then get a 1. You could roll something else, get a 1, and then roll something else. Or you could roll a 1 first and then get 2 other results that are not the same. So as with the other example, there are 3 ways that can happen. So we would need to multiply this probability by 3. 3 is equivalent to the fraction 3 over 1. So then for multiplying fractions, multiply all the top numbers together. 3 times 1 times 5 will give you 75. On the bottom, 1 times 6 times 6 times 6 is going to give you 216 yet again. What are the chances of rolling no ones? Well, that's going to be 5 out of 6 times 5 out of 6 times 5 out of 6. And again, since you're not rolling any ones, the positioning of where the 1 falls or where the pair of 1s falls, that's not going to make a very meaningful difference because none of them are going to be 1s at all. 5 times 5 times 5 is 125. 6 times 6 times 6 is still 216. Here they say, what are the chances of rolling a 1, then rolling a 2, and then rolling a 3 in exactly that order? So we don't have to worry about mixing and matching results here. We've just got a 1 for this one, a 2 for that one, a 3 for that one. Well, guess what? Rolling a 1 is 1 out of 6. Rolling a 2 is 1 out of 6. Rolling a 3 is 1 out of 6. Just because it's a 3, that doesn't mean the probability is 3 out of 6. It's all of them are equally likely. There is 1 of each value on the dice. So 1 times 1 times 1 is 1. 6 times 6 times 6 is 216. That would be the probability of that happening. So next, What are the chances of rolling a 1, a 2, and a 3 in any order? All right, let's think this through here. So you could have 1, 2, 3, or you could have 1, 3, 2. Those are the two situations where 1 is going to come first. Let's suppose we roll a 2 first. So you could have a 2 and then follow that by either 1 or 3. Or you could have a 2 and follow that by a 3 and a 1. Lastly, you could have the situations that start with a 3. So you could have a 3 followed by a 1 and then a 2. Or you could have a 3 followed by a 2 and then a 1. So altogether, there are 6 ways that this can happen. So from before, the chance of getting a 1, a 2, or a 3, well, that was 1 out of 6 times 1 out of 6 times 1 out of 6. And then since there are 6 different possible ways that can happen, we're then going to multiply that by 6. If you do that, that is going to give you 6 out of 216. And if you reduce that fraction by a 6 on top and bottom, you will end up with a 1 in 36 chance of that event happening. What are the chances of getting only odd numbers? Well, the chance of rolling an odd number, there are 3 of them, 1, 3, and 5 on dice. So there are 3 ways of getting odd numbers on a roll of the dice. So there's 3 out of 6, 3 out of 6, 3 out of 6. You could simplify all of those and call it 1/2 times 1/2 times 1/2. Or if you want to be super sneaky, you could call that 1/2 to the 3rd power. But 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And you will obtain 1/8. The chances of getting no odd numbers. Well, fun fact, that's another way of saying getting all evens. So this is really going to be just like what we just found. There's a 1/2 chance of getting an even for the first one. There's a 1/2 chance for getting an even for the second one. And there's a 1/2 chance for getting even for the third one. There's a lot of getting even going around here. Eye for an eye and the whole world goes blind, as they say. So that is also 1 out of 8. And then our last example here, they say a standard 6-sided die is rolled 3 times. What is the probability of getting some odds and some evens? Okay, well, let's think this through in terms of odds and evens. What are the possible ways this could happen? So let's just start making a list. You could have even, even, even. You could have even, even, odd. You could have even, odd, even. You could add odd, even, even. Let's see. You could have all odds. You could have an odd, and an even. You could have an odd, an even, and an odd. Or you can have an even, an odd, and an odd. There are 8 ways total. So because it says some odd and some even, we're basically not interested in the only evens, and we're not interested in the only odds. This, by the way, you notice the answer we got before. This was the 1 in 8 chance of all evens. This is the 1 out of 8 chance of all odds. So from a list, that's where that result would come from. So getting some mixture of evens and odds, that's basically going to be the remaining 6 out of 8 ways that this could happen, which is another way of saying 3 out of 4. Another way you could figure that out is the complement, because the complement of all odd and all even, which we just found, that would be another way you could figure this out. So this would be the complement of all odd and all even. So you would do 1 minus 1/8 minus another 1/8, because from the results that we did previously, there was 1 in 8 chance of getting all odds. There was a 1 in 8 chance of getting no odds. And so this is 8 out of 8 minus 2 out of 8, because you're subtracting 1 twice. And that would also give you 6 out of 8, which is another way of getting to 3/4. So that is the multiplication rule and various applications of it. So when next we meet, we're then going to move on to talking about the general multiplication rule and also start talking about conditional probability, which will be good times.